In Chapter 1, Section 6a, we're going to get to some other types of equations, some polynomial equations that we're going to solve. However, these are much more complex looking than the ones we've done before, and so they do require us to be a little bit more careful in not only how we solve them, but also the math, the computation involved, and in checking our answers at the end for extraneous. Okay, the more complex the equation is, the more likely room for error there is. So, the list, the standards or the steps is, obviously many of these polynomials can be factored out. Like you can take a GCF out. That's just for any kind of equation. If there's a GCF possible that you can take out, you definitely want to do that. If the variable on the first term is the square of the middle term, you can use substitution to simplify the polynomial. This is an interesting method, and I'll show you as we get to it. So let's just start out with this. Now notice this is just 3x to the fourth equals 48x squared. And so there's really only two terms here. So this is going to be one where we're going to want to set it equal to 0 to start out, okay? So we're going to want to subtract the 48x from the left side and the right side. So we're going to get minus 48x squared equals 0. Now we're going to look and say, is there a GCF? And there absolutely is. We've got 3x squared is the GCF, and it's going to leave us with x squared minus 16. And then you notice that x squared minus 16 can be further simplified. You know that that's x plus 4 and x minus 4. And so here we've got our three factors that created this. And when we're solving, remember that we set each factor equal to 0. So we divide both sides by 3. We get x squared equals 0. And x is 0. Obviously, if you take the square root and the square root, you're going to get x is positive or negative 0. But again, 0 can't be positive or negative, and so it's just 0. And then this one here, x plus 4 equals 0. So x is negative 4. And here, x minus 4 equals 0, so x is 4. And notice that we have three solutions. We've got 0, negative 4, and 4. Now, one interesting thing is that, remember when we dealt with linear functions, right? We dealt with linear, and x was to the first power, and most of our answers had one solution, never more. It had one, none. It did have infinitely many in some special occasions, but it basically had the highest degree or exponent was 1, and therefore the solution was one solution. When you dealt with a quadratic and x was squared, you always ended up, in most cases, with two solutions. Sometimes you had one or none in some weird cases, but basically the power or the exponent of that leading term usually tells you how many solutions you're going to get, and those solutions are between real and imaginary solutions, okay? So notice here we only had three solutions. However, this was an x squared, so this was really 0 two times. So it was really like 0, 0, negative 4, and 4. But again, we don't need to write it twice. So technically it did have 4 solutions, but again, if it's repeated, we don't have to include them. So it is a kind of a guide, like this one here. It should end up with 4 solutions, okay? Let's see what happens. So again, here I'm going to factor out a GCF. It's going to be 3x squared. That's going to leave me with 3x squared minus 4 equals 0. And again, if 3x squared equals 0, x squared equals 0 divided by 3, so x squared is 0. And, you take your little square roots, and you get that x is equal to 0. And then here, 3x squared minus 4 equals 0. I'm going to solve for x squared. So I've got 3x squared equals 4. X squared equals 4 over 3. And square root, plus minus. X equals the positive and negative square root of 4 over square root of 3, which again, I'd have to rationalize, right? So plus minus 2 radical 3 over 3. And so here's 2 more solutions. And so I have 3 solutions, but again, this one, because this is an x squared, that one was repeated. And so these become my final answers. When I go to number 3, again, notice here I have this huge 4-term polynomial. Now, we've talked about 4 terms before, and we know that with 4 terms, we could factor out the GCF of each one. Notice there's no single GCF of the whole thing, so The GCF of the first two terms is x squared. It leaves me with x minus 3. The GCF of the second two terms is plus 3, which leaves me with x minus 3 as well. So that x minus 3 becomes one term, and then x squared plus 3 is the remaining term, and now I'm going to solve. So x minus 3 is 0, so x equals 3. I come over here, x squared plus 3 equals 0. And so I'm going to get x squared equals negative 3, and then square root plus minus square root. And so I get x equals plus minus I radical 3. And so notice that I have 3 solutions, and notice my highest power is 3. Okay? We keep going here. Now when I look at this, I look at these 4 terms again. I make sure I can't take anything out to start, which I can't. So then I go to the first 2 and I take out the GCF. I go to the second 2 and then I take out the GCF. Notice my GCF is the same, so it's the GCF here, and it leaves me with x squared minus 2 equals 0. Again, here to solve, you always set each factor equal to 0 and find the x value that makes that happen. So x squared minus 2 is 0, so x squared is 2. Square root plus minus the square root, so x equals positive and negative square root of 2. And so notice I have 3 solutions, 5, positive radical 2, and negative radical 2. And that's what I'm supposed to have. So again, these are pretty straightforward. These aren't too complex. They're going to get harder, much harder. Let's go over here. Now we look at this one, and it's a trinomial, but if you notice, you've got a GCF that can definitely get factored out. So when I look at this first one, I see that I can take a 3 out of it. So I'm going to start with that. I can also take an x. So I've got 3x, and that's going to leave me with 2x squared minus 9x minus 118 equals 0. And so once I get to here now, I'm like, okay, can I factor anything out of here? So obviously it's a trinomial, so you have different ways of doing it. I know that, guessing and checking is one way. You know that I kind of do a times c is negative 36, and it has to add up to negative 9. And so I'm like, all right, I know that these factors are going to be negative 12 and positive 3. So remember how I taught you with grouping, or not grouping, but when the a is not equal to 1, you're going to rewrite it. Instead of as 3 terms, you're going to rewrite it as 4 terms. The first term stays the same. The middle expands to the minus 12x plus 3x, and the last term stays the same. And so now I'm going to factor, again, this 3x is just going to kind of keep dropping down, right? But in here, I know I'm factoring out the GCF. It's 2x. It leaves me with x minus 6. The GCF of this group is 3. That's going to leave me with x minus 6 as well. And so I know then that the x minus 6 is going to be one factor. The 2x plus 3 is going to be the other, and it equals 0. And so now I've got these 3 factors down here at the end. So 3x equals 0. That means x equals 0. I've got x minus 6 equals 0, which means x equals positive 6. And I've got 2x plus 3 equals 0, so 2x equals negative 3, which means x equals negative 3 over 2. And so I got 3 solutions here. And again, notice it's an x to the third, so that's what I should have gotten. Okay, we're going to keep going over here. Now here we've got this x to the fourth, x squared, and 2. And so this is a pretty special scenario here. There's no GCF to pull out. Some of us don't have a problem with factoring with an x to the fourth. What happens is, notice that in a traditional quadratic, you've got an x squared plus x plus whatever, 5, right? And notice that whatever this exponent is, the middle term is always half of it. And so that's your typical quadratic scenario. So here, notice that the middle term is also, the exponent is half of the outer one. And so the only difference in these is that when I create my binomials, instead of creating binomials that are x and x, my binomials are going to be x squared and x squared, okay? So I'm going to show you how to solve doing that, but I will show you an alternative method if you find this confusing. And I'm going to use the alternative the rest of the day, okay? So what I'm going to do is, again, my product is still the same. My product has to be 2 and my sum minus 3. So I know that's minus 2 minus 1. So this is going to be x squared minus 2 and x squared minus 1. Notice when I FOIL it, I'm going to get x squared. I'm going to get minus 1x minus 1x squared minus 2x squared. That's minus 3x squared. And I'm going to get a plus 2. So these factors work, okay? So again, the only difference I accounted for is instead of just being x and x, it's x squared and x squared. So now I have to ask myself, however, when I factor this, because it's an x squared, can I factor this further? This one, the answer is no, it's fully factored because this is not a perfect square. However, this one can be factored more because notice it's a difference of squares. This is an x minus 1 and an x plus 1. And so again, they all equal 0. I make each one equal to 0. X squared minus 2 is 0, so x squared is 2. So x equals a plus minus square root of 2. That's 2 solutions. X minus 1 is 0, so x equals 1. That's a third solution. And x plus 1 is 0, so x equals negative 1. And there's my fourth solution. Again, x to the fourth power, 4 solutions. Makes perfect sense, okay? So now I'm going to do an alternative way. Instead of redoing the same one, I'm just going to do this one an alternative way. So what we're going to do here is, what we do is we take this middle term and we say that x squared equals u, okay? So if x squared equals u, and I'm going to rewrite this, right? Then I know that the first term is x squared squared minus 7 times x squared plus 12 equals 0. And since I made x squared equal to u, this is going to be u squared minus 7u plus 12 equals 0. Now this is more what you're used to with the squares, okay? And the reason we do that, again, is because you're used to that method. It's a little bit more traditional. And so here we know our product is 12, our sum has to be negative 7, and we're like, oh, that's negative 4, negative 3. So this is u minus 4 times u minus 3 equals 0. So we come over to here and we're like, okay, u minus 4 is 0, so u equals 4, and u minus 3 equals 0, so u equals 3. Now, when we get to here, we're going to replace back in or substitute in what u really is. We're saying x squared equals 4 and x squared equals 3. Now that I have that, I'm ready to solve for x, right? So I'm like x equals plus and minus 2, and I take the square root, and x equals plus minus square root of 3. And I find my answer. So the only benefit to it is when the factoring part of it, instead of having the fourth and this and that, we basically convert it to u, make it a quadratic with u, and it kind of makes it a little bit easier, I think, for some of you. So again, we'll do it again, we'll do it a few times. Again here, we're going to make x squared equals u, okay? So x to the fourth is the same as u squared, right? So this is going to be 9u squared minus 37u plus 4 equals 0. Again, this is a nasty problem because, again, I got to multiply it, and I know that my product has to be 36, my sum has to be negative 37, so I'm like, okay, that's minus 36 minus 1, so let's expand this out. First term stays the same, middle term expands, and the last term stays the same, and I'm going to solve by factoring out, right, by grouping and factoring out the GCF of the first group, leaves me with u minus 4, and then the GCF of the second group, which also leaves me with u minus 4. So u minus 4 is my first group, and 9u minus 1 is my second group. So now that I have it here, and I've kind of simplified it and factored it, at this point now, every place where there's a u, I believe that I could sub in the x squared. I could even wait one more step. So u minus 4 equals 0, and 9u minus 1 equals 0. I can wait until I get u isolated, just to keep it neater, right? So plus 4. So u equals 4. 9u equals 1. U equals 1 over 9. Now that I have it down to u, now I think is when I should sub it back in. So x squared equals 4, and x squared equals 1 over 9. So again, how do I get x squared? I take the positive and negative root of that right side. X equals plus minus 2. There's two solutions. Plus minus. X equals plus or minus 1/3. And there are my 4 solutions. Again, 4 solutions is what I should have gotten. So again, the u makes it a little bit easier. I mean, again, I can kind of do it without having to do that, but if you're struggling, I think the u makes it a simpler process. So now we're going to get to some harder ones, right? Now we're going to start adding, we're going to start solving, or basically we're still solving, right? The difference is, if you look at it, same kind of concept, except for the fact that now you have variables in your denominator, which definitely take this to another level, right? We were still adding, terms and everything, but you've got these denominators. So again, remember, we learned to do this before. Just remember that when you have these variables in the denominator, now you have to start checking for extraneous solutions, right? Because again, something might mathematically work, but might not be okay in that problem. So again, when you have a situation like this with a denominator, what you want to do is multiply by your least common denominator, okay? So we've got an x and an x squared. So if I multiply everything by x squared, my denominators will cancel out. So when I multiply the 1 by x squared, it could look like that. When I multiply 3 over x, this x is going to cancel, but it's going to leave me with the 3 up top and 1 additional x to multiply. When I multiply this term, the negative 2 over x squared, those x squareds will cancel, leaving me with just negative 2. So notice I've got x squared plus 3x equals negative 2. Now again, they're asking me to solve, which means this is a quadratic. I'm going to have to bring everything over to the left side, so I'm going to have to add 2 to both sides, because I got to get it equal to 0. I need a product of 2 and a sum of 3. That's easy. That's 2 and 1. So x plus 2 times x plus 1 equals 0. So x plus 2 is 0. So x is negative 2. And x plus 1 is 0. So x is negative 1. Now, these are my solutions. However, remember that I have to check for extraneous. So I have to go back into this original problem and say, well, what can x not be? And in each of these, x cannot equal 0. That's the one it can't equal. So negative 2 is fine, and negative 1 is fine. So we're good. We come to this next one. Notice it's an x to the 4th. So again, we can do what we know how to do. We know that u is going to equal x squared, and u squared is going to be x to the 4th. So we've got u squared minus 3u plus 2 equals 0. Again, products, multiply to 2 and add up to negative 3. That's minus 2 minus 1. U minus 2 times u minus 1 equals 0. U minus 2 is 0. U equals 2. U minus 1 is 0. U equals 1. X squared equals 2. So x equals plus minus square root of 2. And x squared equals 1. So x equals plus minus square root of 1, which is plus minus 1. So here are our 4 solutions. Again, the x is not in the denominator in number 10, so I don't have to check for extraneous in this one. All right, so now we get to really starting to get to some tricky problems now, right? So now we've got x plus 1 to the 2/3 power minus x plus 1 to the 1/3 power minus 2. And again, if you notice, right, this exponent here is 2/3, and this is half of 2/3, which is 1/3. So this is, again, another one where I can use u for. And this is probably the best example of when to use it, okay? So for this problem, what I'm going to do is I'm going to make u, right? I'm going to make this entire thing equal to u. So I'm going to do x plus 1 to the 1/3 power equals u, okay? And I'm going to make x plus 1 to the 2/3 power equal to u squared. Notice that if I square this, right, it's going to be to the 2/3 power, okay? So it's fine. So it's going to be u squared minus u minus 2 equals 0. And so again, my factors have to multiply to -2 and add up to 1. So it's going to be, or -1. It's going to be -2 plus 1. So I've got u minus 2 times u plus 1 equals 0. U minus 2 equals 0, and u plus 1 equals 0. So when I do the math here, u equals 2, and u equals -1. So now I'm ready to plug back in what u equals here, right? So if it says u, I know then I'm saying x plus 1 to the 1/3 power equals 2. And same thing for this one, x plus 1 to the 1/3 power equals -1. So these are two separate things, right? So now I come over here to the left and I'm like, okay, what do I do? How do I get rid of that 1/3 power? Well, we know that if we take a power to a power, we can multiply it, right? So I got to think of, well, what could I raise this to? What power could I raise this to that would completely eliminate this fractional power here, right? Notice that this is equivalent to the cube root of x plus 1. Well, how do I cancel out a cube root? Well, I cube it, right? Because this 3 and this 3 would cancel. So really what I'm doing with the 1/3 power is I'm going to take it to a 3rd power. Because notice that 1/3 times 3 is 1. So whether you want to convert it to a cube root and raise it to the 3rd power, or you want to recognize that 1/3 times 3 is 1, either way it's going to work, because when I take the 1/3 to the 3, I'm going to get x plus 1. So if I cube the left, I have to cube the right. And so I get 8. So now I've got x plus 1 equals 8. So x equals 7. And believe it or not, that is my solution there. Okay? Now, I come over to the other side, and I see here, again, x plus 1 to the 1/3 power equals -1. Again, if I cube this side, these are going to cancel, leaving me with just x plus 1, so I'm going to cube this other side. And then -1, x equals -2. And so you have two solutions here. You have a 7 and you have a -2. Now, again, you can double check yourself and you can see if it works. Like 7 plus 1 is 8, and 8 to the 2/3 power is the cube root of 8 squared. So cube root of 8 is 2, and 2 squared is 4. So this whole thing equals 4. You come over to here, and you do, again, minus, that's 8 to the 1/3 power. Well, that's 2. So that's 4 minus 2 is 2, and 2 minus 2 is 0. And so it works. And again, if you do the same thing with -2, you're going to see that you get the same answer, that it does work, okay? So in this situation, I really do see the benefit of doing the whole u thing, okay? But again, the u thing can only work, and it only works when the exponent of the first term is double the exponent of the second term, or the middle term, rather, is half of the other one. So again, in this case, I'm going to make, let me see what I got here. I'm going to make 2x minus 1 to the 1/3 power equal to u, and 2x minus 1 to the 2/3 power is equal to u squared, okay? And so here I'm going to have u squared plus 2 times u minus 3 equals 0. So again, I have to multiply to -3 and add up to 2, so it's going to be plus 3 minus 1. So it's u plus 3 times u minus 1 equals 0. U plus 3 is 0, so u equals -3. And u plus 1 is 0. Oh, sorry, u minus 1 is 0. My bad. U minus 1 is 0, so u equals 1. So now that I got it down to what u equals, I'm ready to substitute u in. So I know that 2x minus 1 to the 1/3 power is equal to u, so I sub it in. And I do the same thing over here. 2x minus 1 to the 1/3 power equals 1. So basically there's that side, right? So let's solve this left side, and I know again that something to the 1/3 power is a cube root. And how do you get rid of a cube root? You cube it. So I'm going to do the same thing to both sides. These will cancel, and I'll get 2x minus 1 equals negative 3 cubed, which is negative 27. Add 1 to both sides, that's negative 26. Divide both sides by 2, and it's negative 13. And that side's done. And then let me come over to here and get this side. So again, how do you get rid of a cube root? You cube it. So I cube both sides, and I get these cancel. 2x minus 1 equals 1. Add 1 to both sides, 2x equals 2, and x equals 1. And so my two solutions are negative 13 and positive 1. So again, we come over here and you see you're in that same scenario here. You've got here this expression to the second power and then the same expression to the first power. So again, this is another classic case where I think it's going to be easier to turn it into u. So what we're going to do is we're going to make x over x plus 1. We're going to make this middle one equal to u, and that'll make the first one, right? That's going to be u squared, like that, right? So I'm going to come over to here, and I'm going to do 6 times u. Actually, and I don't even really have to write that, but whatever. Okay, 6 times u squared, right? Let me just do it like this. So I've got 6u squared plus 5u minus 6 equals 0. So again, I know that I need a product of negative 6 and a sum of 5. So I'm like, all right, what is that going to be? So it's going to be plus 6 minus 1. So, oops, I can't do that actually. Sorry. I notice here I have an a value that's 6. So unfortunately, when I do this, it has to be negative 36 and a positive 5. And so what numbers multiply to negative 36 and add up to 5? And it's 9 and negative 4. But again, because this is a is something other than 1, I have to remember to do first term stays the same. The second term divides into 9u minus 4u, and the last term stays the same. GCF of the first term leaves me with 2u plus 3. GCF of the second term leaves me with 2u plus 3. And again, the 2u plus 3 is my GCF. And then my 3u minus 2 is my other factor, equals 0. And again, I'm ready to solve. 2u plus 3 is 0. 2u equals negative 3. U equals negative 3 over 2. 3u minus 2 equals 0. 3u equals 2. And u equals 2/3. So now that I've gotten to here, I've figured out what u is, but remember that u is not what I'm looking for, right? I'm looking for x. And so I have to substitute back into this problem what x is, right? Or I have to sub x back in. So I know that u is equivalent to x over x plus 1. So x over x plus 1 equals negative 3/2. And so what I'm going to do here is I'm going to do my cross multiplication. Because this is a proportion, really, a fraction on the left equals a fraction on the right, I can solve these using proportions, which kind of I like, because definitely much simpler. Okay, so I come over here and I'm like 2x equals negative 3 times x plus 1. So I'm just going to distribute negative 3x minus 3, add 3x to both sides, and divide both sides by 5. And I get that x equals negative 3/5. So I got one solution. Now I come over here, and again, I know that u is equivalent to x over x plus 1. And again, I'm going to use proportions here. So 2 times x plus 1 equals 3x. 2x plus 2 equals 3x. Subtract 2x from both sides. 2 equals x. And that's the answer. So x is 2. So I have my two solutions, and it was that simple. Okay, so I mean, not really that simple, but And then we'll do one more. Again, we have here a radical, and we see that we have 7 times the square root of x. Well, remember that the square root of x is the 1/2 power. And if you notice, 1/2 is half of 1. And so this is still in that kind of like that quadratic format. So I know that I can make u equal to the square root of x, which is also x to the 1/2 power, okay? Which means u squared is going to equal x to the first power. So this is really 6u squared, rather, minus 7u minus 3 equals 0. So again here, I'm looking at a trinomial with an a value that's other than 1. My product would be minus 18. My sum is minus 7, which gives me minus 9 and positive 2. Again, since it's a trinomial with an a value other than 1, I expand it to 4 and solve by grouping. So again, first term stays the same. Second term expands to the 2 terms you found here. And then we get minus 3 equals 0. GCF of the first two is 3u, which leaves me with 2u minus 3. The GCF of the second one is a this should be a plus here, sorry. This is a plus. So it should be plus, actually just a 1, sorry. That's a plus 2, and there's no GCF, so it's going to be plus 1. It's going to leave me with a 2u minus 3. That 2u minus 3 will be my first factor, and then the 3u plus 1 is my second. And now, again, I'm ready to start the solving process. The factoring part's done. Now I'm going to get to the solving. Add 3 to both sides and divide both sides by 2. So I get that on the left. And 3u plus 1 is 0. Subtract 1 from both sides and divide by 3, and I get this. And so now I have, again, u equals this and u equals that. However, I'm not trying to solve for u, I'm trying to solve for x. So now I'm going to substitute back in. I know that u is equal to the square root of x. So the square root of x equals 3/2. How do I get rid of a square root? I square it. So I do the same thing to both sides. So x equals 3/2 squared, which is 9/4. There's one solution. And then I do the same thing over here. Square root of x equals negative 1/3. How do I get rid of a square root? I square it. Do the same thing to both sides, and I get x equals 1/9. And there you have it. So you have your two solutions there as well.